Yes. Yeah. Okay. Are you able to see?
Yes, sir.
Okay. So, yeah. I'll be talking few short learning, and it's of course a general one. Bit what specific to the handwriting recognition, because I'm taking a couple of studies on handwriting recognition. Of course, the theme says that it's a biometric and integrated with the forensic applications. Of course, I can also include a couple of biometric traits like handwritten, signature, and so on. So myself, Manjunath Aradhya, I'm working in the Department of Computer Applications, JSS Science and Technology University, and you can note my email ID aradhya@stc.ac.in. If you have any clarification, doubt, comments, and also feel free, very free, to write anything related to these, possibly for future collaborations. Okay, so first of all, these few shot learning is very unmature in the field of machine learning. So I think people are aware with many of the machine learning techniques, traditional machine learning techniques. So of course, people are well aware with the aspect. But when coming to the one-shot learning or a few-shot learning, where it is very unmature, and so probably very little amount of what work have been done in the recent past. So probably I can take from 2018, 16, something like that, and hardly what we will see. Very few papers, and of course it's a very challenging, of course, for me to really give some sort of direction initially. So probably like past 1 year or so, what we are working in this line, starting from last year 2020 April May. So we did something with respect to the COVID related data. So we worked on one chart, and then so probably we had some sort of knowledge and things. So probably be helpful for me to share some of the aspects. So feel free to interrupt me in between if you didn't get, or if you have any sort of questions or something like that, and let's make this session interactive. So first and foremost is the these are the top. These I go I'll be talking more on concept learning, the importance of concept learning with respect to the human cognition system, and then how really what these concept learning of with respect to the human is what will be seen with respect to the humans. That's what all about the one-shot learning, the three-shot learning, and the motivation and challenges. And also what I'll try to focus some very important things with respect to the learning problems and the core issue that leads, especially with respect to the OSL or the FSL. OS means one-shot learning or the few-shot learning. And so probably this case study will be handled in the next session. So probably till core issue, what we'll try to cover in this session. So let me ask a simple question like, what do you understand when you talk about human cognition, or simply head cognition is all about? Can anyone tell me, please? What exactly human cognition is all about?
Mental ability of the brain.
Okay, mental ability of the brain.
Yeah,
okay.
Of the human. There are three sections, the motor and the mental ability. So cognition deals with the mental ability.
Okay. So what it does actually, when you talk about human cognition, what it does?
So it deals with the behavioral aspects.
Okay, very interesting behavioral aspect. Any other things?
Sir, actually it is having ability to recognize with one or two samples. If I see a photo of one sample,
okay,
I can recognize the same person even after 3-4 years with
okay. Okay, so you have a sort of ability to recognize or to do some other stuff. Okay, fine. And someone told with respect to the behavior, yes, that's good. Any other overall, when I talk about cognition, do you really think that human cognition is meant only to solve some of the very simple problems?
not limited to simple, from the
Okay.
simple to complex.
Okay, that's
So
true.
deal with any situation, anything.
Okay, that's great.
Based on the experience.
Okay, that's great. So this is how what I'm going to interpret the cognition, human cognition. So probably like when you see this particular dipset, so probably you can understand very clearly it is with something like you have sort of what input, and finally you will be what throwing some sort of output, and you have inside in the middle, so probably what you can call it as some human brain. So I can easily relate these two with respect to the computer system. Like you have a input to the computer, and finally what you are expecting something out of it, and finally there is a what intermediate. So something I can call it as an algorithm or CPU or something like that. So probably whatever the input you have, so probably what it will you get with some sort of desired outputs or thoughts. So when I talk about human cognition, so probably as I mentioned that it is not really meant for solving some simple problem. So probably when I talk about the human cognition system, it is really what meant for to solve many what complex problems. And very importantly, when I talk about human cognition system, normally what it includes 4 different types of categories. It's something like the first and foremost is the acquisition. That's very, very important. And when you talk about acquisition, the next comes with respect to the knowledge. Once we have a knowledge, so probably use those knowledge to manipulate, to do some sort of updates, and finally, what you produce the action or the behavior. So when I talk about the human cognition, the 4 what things comes into picture. One is the acquisition, is nothing but the information, something like that. Acquisition, and the second one is with respect to the knowledge. Once we pursue the acquisition, so probably what it is some sort of what knowledge to us. You use that knowledge, you store that knowledge, and to solve many of the things. So your friend told something like face recognition or something like that. Let's take an example. For the first time I come here, and finally I will show my face for 2 or 3 seconds, and then I go back. Let's take an example. If I come after a day or 15 days or 30 days, so probably after a month. So probably you have a human ability to really recognize the face, saying that, okay, I have seen this guy somewhere long back, or something like that, saying that he was delivering a talk or something like that. So probably you use that knowledge, and finally whenever you require, so probably you can bring it out with respect to action or a behavior, something like that. So human cognition, again I will repeat that it is not made only with respect to solving a simple problem rather than the complex one. So the next question what I want to pose is that why do you want to learn? Why humans want to learn? Of course, so probably in the previous slide only I gave sort of insight. So probably in that way what we can understand quickly what we can tell the answer, and finally then we can move to the next slide. So why do we have to learn, humans? So that's very simple. Like we have to learn because we have to solve some problem. Day to day, probably we have many stuffs coming to our picture. So probably we need that one. We have to update ourselves, and so probably want to solve many of the complex problems in this real world what we get. So this is why normally humans have to learn. The next fundamental question normally I ask is why a machine has to learn. So any answers for that? Why machine has to learn? Why learn? Nothing but why machine has to learn? Can anyone?
Machine is more efficient to do work than the human.
Okay.
So if anything done manually, so instead of doing manually, it is more efficient when it is done by the machine.
Okay. So you are talking about the effortless, right?
Pardon, sir?
The effortless?
Yes, sir.
Okay. Any other apart from that in the audience? Why we are really making machine to learn these days? So you take from 2009, 2005, many people talk about artificial intelligence, many people talk about machine learning, and people now talk with many other robots, that is and all. Why we have to why we want to make machine to learn?
We want a machine to respond to unseen scenarios.
Okay, very interesting. Unseen scenario, right? And another thing apart from that?
To reduce the human error?
Yeah, okay. Error, effort, or many other things. Okay, that's fine. Any other interesting thing?
Time.
Time, that's okay. Effort, I said. Some more in one of the
To increase
sets.
the accuracy regarding real-time problem?
Okay. Okay, all that's fine. Apart from that, any other interesting things? Like, I think you people are aware with respect to recent activities that's been taking care with respect to the spacecrafts.
To
field.
replace a human place, I mean, wherever human is required in place of that, is it possible to replace the machine there?
Yeah, so like I will take your answering this way. So when you don't have a human expertise, when you don't when there is no human expertise exists, so probably like in that case, so probably I need a system which is very robust or very intelligent sort of thing. So probably what to solve the needs of the days. So probably like let's take an example with respect to the spacecraft recently what been taking care with respect to the Mars or Moon or many other things. So probably humans doesn't exist in Moon or Mars. So probably I want to learn a system like the surface of the other planets or any other thing. So probably in that way we need an intelligent system. So those intelligent system probably whatever we develop really what solve some of the what human needs. So apart from that, as mentioned from many of us, so probably like reduce the effort, time, and many other things like that. The expertise with respect to the speech processing are really what coming to the biometric solutions to be updated to a particular case. Like you can these days you see many things, many stuffs with respect to the biometrics, like entry system, exit system, or attendance, or whatever. So probably like we need some sort of what application where really what reduces the human effort. So this is the first fundamental reason is something like the human expertise I require, where you don't have any what doesn't exist. So in that case, so probably I need a system to be what do certain task. Okay, I don't take much of time here in a couple of 1 or 2, 3 slides, so probably I'll be directly moving. But anyhow, for the sake of completeness, I will just do the key things with respect to the learning. When I talk about learning, it is with respect to the 3 important learning categories I can make. One is supervised, everyone know, unsupervised, and reinforcement learning. When I talk about supervised, it is something like you learn through a teacher. When I talk about unsupervised, you don't have any teacher to what learn. So probably what you learn on the go or the fly. And when you talk about reinforcement, nothing is something like sort of decision making. So could be examples with respect to the gaming, artificial intelligence, or robots, or something like that. So very quickly, what I can run these. So this is what the category is all about: machine learning, supervised, unsupervised learning, and reinforcement. Of course, we have a category with respect to supervised, unsupervised, and reinforcement. So supervised can be what categorized again into a classification and regression problem. Unsupervised is again the clustering and the dimensional architecture. And when I talk about what reinforcement learning, so probably all these many other applications comes into picture. So let me quickly tell you something with real examples where I can bring the differences between the supervised learning and the unsupervised learning. So all this is very important because for my stuff on FSL or OSL, so probably the supervised machine learning, many other parts are necessary. Okay, so when I talk about supervised, I think we're all aware with respect to the Cortana, right? It's a speech automated system that been existed in the existing operating system like Windows recent edition. So where it's like a free hand system where you simply express your views. Let's take an example. You tell a system to open certain file or do some sort of process or something like that. In that way, what Cortana, the speech automated system, sells us, and also what recent thing like Alexa or the Google Assistants, where it's all about the speech automated system. It learns the human speech and finally what reacts or do some sort of actions. And also what I have given some of the other examples like OCR systems, spams, Categorizing to these incoming what days. So probably what you can see in the email system, we have what a category saying that spams and non-spams, and also very recently introduced in the many mobile phones like messages also, incoming text messages being what categorized into spams and non-spams. Many of the Android applications where you can see, so probably what there is a category of separating the incoming messages with respect to the spams and non-spams, and also what with respect to biometric attendance system, wherever see in the organization, it could be in the what industry, or it could be in the these setup like colleges or universities. So probably one or the other way. So probably people are using biometric attendance to reduce the effort or something like that. So when I talk about unsupervised learning, so probably here in the supervised, you have some sort of what teacher, nothing but you have some sort of class information for a particular object or the particular sample. Whereas in the unsupervised learning, so probably you don't have any class information. It's totally what unaware about what the data is all about or something like that. So the one way how we have to solve the problem with respect to the unsupervised learning is that on the fly only what we have to solve the thing. So you have a data, you have to come up with some sort of model, and finally what you have to categorize into different what needs. So probably it all depends upon the application. So let's take an example. I have an application that my friend calls for me a party, and then so probably I meet all the strangers for the first time. And when I on the fly, so probably I have to classify them into like my you have a data of the people. So probably I can categorize into gender, like male and female, or with respect to the clothing, or with respect to the age groups, or with respect to the behavior, or many, so something like that. So also let's take an example. You are watching the cricket or golf for the first time. So probably based on different criteria, what you can be able to classify and finally categorize into different fields. Okay. Okay, these are the simple ideas that I gave with respect to what learning and why we have to learn, and then the categories of learning and so on. Now, very importantly, let's move on to the entirely different view with respect to the traditional machine learning. Now, the thing with respect to the concept learning. So, what exactly the concept learning is all about? So, this is where the idea of what concept learning you're taking, and finally now they are bringing into the machine learning, and finally able to solve some of the very important problems that do exist in our real world. So let's take an example. Consider a child of age 6 or 5, something like that, where it can recognize what many different objects are categories. Let's take hundreds of different objects are category. What objects it can recognize, and it can easily separate from one to another one. So how really what it comes means it's all about the human ability. We have a super human ability to learn concepts with very, very few examples, or in some cases is only one example. Now, I told in the beginning of my class saying that I come to let's assume that the coordinator introduced me and I showed my face, for 2 or 3 seconds, and finally I turned off my camera. And let's take an example, after a month or after many days, so probably if I appear to someone of you, so probably you are able to recognize me, saying that okay, he's Manjunath Aradhya, he was delivering the talk, something like that. So probably that is what the ability the human have, and of course we are blessed to have that sort of ability to really learn the concept with very, very few examples. Okay, so this has resulted with the unique properties that is exhibited while learning. So probably I can have some sort of properties with respect to the learning concept, and I can categorize it to 3 different ways, or the 3 different properties. So the first one I call it as compositionality. The second one I call it as causality, and lastly, very important, is the learning to learn, or sometimes I can also call it as meta learning. So learning to learn, causality, and compositionality. So let us try to understand what is this exactly. So compositionality is nothing but, let's take an example, you have an object, and finally what humans are very good in identifying its parts and subparts. Let's take an example. If you show a face, human face, so probably I'm able to recognize the subparts like nose, eyes, mouth, or something like that. Or otherwise, when I give a plant as an example or an object, so probably you're able to tell you the roots, the branches, the stems, or something like that. So that is where like the compositionality comes into picture. Let's take an example with respect to here. I'm showing some of the handwritten numerals from 0 to 9, and compositionality is, let's take an example with respect to these 3. So compositionality is nothing but identifying with respect to the subparts. Like when 3 happens to be something like this, so it is something like you have 2 semicircles, something like that. Okay, so when you talk about any other stuff, something like 4, here you have 1 vertical and 1 vertical with a big one and small 1 vertical and an horizontal one. That makes you an object saying that's 4. And you have another, like as I mentioned, like you have 2 semicircles, so probably 1 to 1, and finally you can make it as up to 3. So this is what the idea of with respect to the compositionality. Again, compositionality is nothing but identifying parts and its subparts. So very interesting is with respect to the causality. This causality is nothing but the relations, the related concept that can be learned by the humans. So now, as I mentioned, like the 3, so you have, let's take an example. You have 2 verticals and 1 horizontal. So probably I can call it as 4. So this is what the relation. Or otherwise, normally, let's take an example. I want to categorize different fruits. Like when I talk about fruits, like all things are dependent in nature, right? So let's take an example of fruit as an apple. So probably the structure, color, and many other things are dependent in nature, 1 to 1. Normally it is dependent, but when you talk about what attributes are, when you extract some features, we call it as it is independent of feature. But forget about that one. When I talk about an object, so probably it is what it is dependent to one another. So the causality is nothing but you have sort of relations, and being with understanding with this relation, try to figure it out what it is. That is what the causality is all about. And last one is very important of our topic. That's what when I talk about the few shot learning that comes, it is learning to learn. What is this learning to learn? So let me take some examples like this. So humans are very kind and ability to have a sort of ability to learn with respect to few examples, and the while learning, so probably something new comes, so probably you're able to tell, okay, that is similar or dissimilar or something like that. Let's take an example in this way. So I show you, let's take an example for a age of 6 or 5, I show some play cards saying that all buses, variety of buses I show. So probably if I show something which is unseen, like if I show the truck for the kid, so probably you have an ability to distinguish or differentiate between the buses and the truck. So probably if I show the double-decker bus, so probably it is able to tell. Even, of course, when in the learning stage, I have not shown anything with respect to the double-decker bus. But if I bring the unseen object as a double-decker bus, so probably what it can able to tell, it is something very similar to the play cards what I have shown. So that is what the idea of learning to learn. It refers to the fact that inducting prayers while learning a particular task that can be shared while learning another task. So I will be talking more with respect to this prior knowledge or the prior idea. So prior knowledge is something like normally in the traditional machine learning, this prior knowledge is entirely missing, because let's take an example. You want to recognize faces. You have face, and then you have a model, and finally you will be classifying whether it is which face or not, something like that. Probably when I talk about model, you don't have any prior knowledge into that. So probably that is of course a very important point to be noted, and with respect to the traditional machine learning. Whereas if you induct this prior knowledge or you use some sort of prior knowledge, so probably machine can easily understand. That is where the idea of what one shot or the few shot learns comes into picture. So I told in the beginning of my class, humans are able to understand with respect to one simple examples are very few examples. So these the prior knowledge with respect to the human brain is something like that. We understand the structure, we understand many other properties, we do many other things. So probably in that way, the behavioral aspect or something like that. And finally, we are able to figure it out. Okay, this is what the person that was he was with me at that time or something like that. So these the idea of prior knowledge that brings you to the model, and so probably you can solve many of the problems if we have very few examples. Anyhow, we will see that a little later. So overall less. So probably when I talk about the concept learning, 3 properties comes into picture. That is one with respect to compositionality, causality, and learning to learn. Learning to learn is sometimes also called it as meta learning. Okay, so here we go into our very important learning aspect, that is one shot learning. So what is one shot is all about? So one shot is something like you are given only one example. You will be given only one example, and finally you have to figure it out using this one example to solve the problem. It could be a face recognition system, or it could be a character recognition system, or it could be a signature or whatever. So you are thrown with only one examples, or very limited examples, and then your system should be able to tell. Okay, so this belongs to this class, or it is different, or something like that. So the whole idea of one-shot learning has brought from the idea of the concept learning, and I told in the previous slide. So we have ability, human have a ability to learn very few examples, of course. So I told you, I told an example by giving only the 5-year child or a 6-year child can do it. So probably the another thing will many more things. So probably bringing that idea and finally teaching here. So probably to solve many of our problems. And you can ask me where in these applications will be coming to deal with respect to the one-shot learning or few shot learning. Anyhow, we're talking on these applications as well. So finally, what I can say is that one-shot learning aims to train image classifier over the database with only one example or a few examples per category. So you'll be given only one example. So probably you have to model it in such a way that probably you can classify it in a better way or the efficient way. Okay. So what is few shot learning? So I can also call it as a low shot learning. Many researchers also quoted as a few shot or low shot learning. Is one of the same. Low shot learning or a few shot learning. So you learn with the limited data, and it is different from the standard supervised learning. I will tell you, I will give a couple of examples to illustrate this, how it is different, entirely different from the traditional machine learning or supervised learning is all about. Okay, so the final, what is the goal of few shot learning is that learning to learn or learn to learn. So we are really not worried to build a model to recognize the images. But the main idea or the key idea with respect to few shot learning is that to find the similarity between the objects. That's it. Let's take an example. You are given with 2 set of images. One is, let's take an example of cat, or another one is the dog. So probably you have to build a model, and finally you have to say that okay, these dog and cat are different from each one another. So probably otherwise, if I want to talk about the similarity, if I given with the 2 cat, so probably as a input to an image, and finally your system should tell, okay, these 2 objects are similar in nature, and finally it has to give some result. So in that sense, the whole idea of few shot learning comes into picture. We are really not worried about recognition system. We are not building a recognition system. Please understand here, we are just finding out the similarity between the objects. Our main intention of few shot learning is that we have to find the similarity between these any 2 objects. Okay, I was talking wherein you see these applications. Of course, applications really plays an important role. Like these days, friends, I can understand that you take an example with respect to face recognition system, character recognition system, object recognition, or many other stuff. So probably you don't have any scarcity with respect to the data. That's I know. Probably when I talk about very important applications where you have very limited limited data, where you don't have really what much stuff or much data. So probably probably what you can handle. So traditional machine learning, what the major problem with the traditional machine learning is that you require huge amount of data, you have to train and etc. etc. Of course, these days what the idea of deep learning is coming, and so probably many are aware with respect to deep learning model, like where you require huge amount of data to be thrown to learn the system, and finally what it gives an answer. Of course, the answers are accurate or something like that. It is in many of the applications it is just nothing but 100%. So, but there are like applications where you have data are limited. When the data are limited, so probably if you throw those data into your existing deep learning model, it fails. So what the problem is with respect to deep learning is that you require a huge amount of data and many more or something like that. So giving with this idea and the key takeaway, so probably there are many applications where you have very limited data. Like let's take an example of law enforcement, forensics, autonomous driving system, language acquisitions and understanding, diagnosing developmental disorders in children. Yeah, these are very, very rare thing. So probably when you have a rare disorders in children, so probably you will be, the data is very, very very limited. Of course, you will get only 2 or 3 or something like that. So probably keeping in mind, and finally you want to develop some sort of recognition system or any other development system. So probably with using this many, so probably you have to come up with something extraordinary or an efficient one. Of course, in a medical field. So I give why I'm telling with respect to medical field, like in 2020 when the COVID came into picture, we had a very, very scarcity with respect to the COVID X-ray images. Especially in the early 2020, like in February, March and all, we had very, very little amount of COVID patients, chest X-rays or the CT scans or something like that. At that time, let's take an example. If we have a FSL model or the OSL model, so probably using one sample or very few examples, so probably you are able to tell whether the patient has the COVID symptoms or whether it's a COVID or not or something like that. So probably now today you have hundreds and thousands of lakhs of millions of patients COVID X-rays, but that is different. But when you tackle the problem with respect to the unseen, like very, very new, it is like COVID, no one expected and finally triggered, and in 2020 early of 2020, so probably there was a lot of scarcity. So with respect to that, so probably the medical field has really we really don't get much data in some of the applications. So manufacturing, of course, so probably I'll put together all these in way. So probably I can tell that when we have a limited data, so probably there is a scope, and there is of course they need to come up with some sort of one-shot learning and few shot learning approaches. So this is what the motivation is all about. The key motivation is that like test-based for learning like human. It's a test-based, like when I talk about few shot, it's nothing but the test-based with respect to the human system. We are just replicating how human thinks, and finally we are putting here, and finally we are doing new tasks. I don't know really like how this overall human brain works or something like that, but what researchers has done that they have taken some sort of replica, whether it is 5 or 10% it does work, I don't know, but probably they have taken something, and finally now whatever you are talking, like whatever you see like artificial neural network, deep learning, the people say that it is replica of human brain or something like that. It's nothing but how parallel processing does or something like that. But anyhow, we have done created the thing model or something like that. But really understanding of course, there is a huge gap with respect to understanding the human brain, and finally with respect to the human systems that do exist now, like when you talk about artificial network or something like that. Of course, there is a great deal of real research requires to learn more on cognition, human cognition. Of course, people are really working on those lines, like when you talk about the neuroscience or something like that. So star cases, that was I said like early in 2020, like when we talk about the COVID. So probably there was a lot of scarcity with respect to the data, and reduce data collection effort and computation. This is of course a very, very important point to what to mention here, because traditional machine learning is something like you require a lot of what images for samples or something like that. Most of the time, our time what went what collecting the data and finally what do all such processes. And also one other very important that when the data are very limited, so probably when there is no much with respect to computation. If the data is used, so probably I have to talk with respect to computation. If the data is limited, so probably thing with respect to computation nowhere exists. So probably in this way, this is the key motivation to come up with sort of few shot learning or the one shot learning to solve some of the needs. Okay, now let's take a couple of examples or cases. I'll be throwing some images and finally asking you, so probably feel free to answer. The case number one is that, you have bunch of images. You can see here, let's take an example. This is what the image I have taken from the MNST. So I think you are all aware with respect to the MNST database. It is a corpus of numerals, English numerals, containing around 60,000 samples, right? And like of 10 classes. And so probably each what classes have a sample of 6,000 to 7,000. It's not constant, uniformly distributed. In some classes you have 5,000 samples and 10,000, 6,000 or 7,000 samples. All put together, we have around 60,000 samples. And you can see our different variations in the handwriting. So probably if you take the numeral 7 here, some people will mark with horizontal line, and this is something like it looks like I don't know which it looks like a cap, something like that. It of course it comes under 7 and all other stuff, something like that, these styles and all. So probably when you have these many variations, when this many behavior things, so probably you train a system in such a way that whatever you throw, let's take an example, I'm just testing this case and just pushing to what my computer is saying, that what is this? So probably given this one, it can directly say this belongs to class number 1. Let's say if I mark this class 1, 2, 3, 4, 5, something till 10, so probably it can easily tell that okay, it belongs to class number 2. So I don't have any problem if I have this bunch of data and finally if you have this sample, so probably I can easily classify to correct classes. Let me go and take the second case. So this is what the second case is all about. So what is this? So you have very limited. Now in the previous case I showed you the bunch of images or bunch of samples, but now in this case I don't have. So I'm really worried with this data, and so finally I have only 2 samples for each class. So this is what the handwriting that represents the Bagalakote, and this is what the Mysore. And now what I am just telling to the system is that I use this as a test case, and this is what my query image. So this is again something tells you about the I know the class information. It is Mysuru. So probably how exactly the machine can predict the correct one. So is the system able to predict traditional machine learning? Can anyone tell me? Can you able to predict? Are you catching my point? Okay, so can anyone tell me can machine predict the correct one with these examples?
Yes, sir.
Is it? So you are just thrown only 2 samples, and I have, of course, let's take an example of 2 classes or 10 class problem. So probably I will be giving only with this information, this is what my test bed. So will it be able to recognize as the Mysuru?
No, sir. Maybe
Okay.
close
close to 70% of cases we can achieve.
Okay, so there is of course a little, of course you have a lot of error when you have what, so probably in this case, probably existing traditional machine learning algorithm may fail what recognizing what as a Mysore or something like that. Because like as I mentioned that you require bunch of data to what train a machine and tell, okay, this is what the character is all about. Something like that, when you give very, very limited, so probably it fails. So this is what normally happens with respect to the existing models. Okay, the case number 3, what it does, you have 2 here. I have only 1 samples of each class. This is Mysuru and Bhagapur. And now what the test case is this one, Kopla. So it's entirely this test case is coming out of unseen class. I have never trained this Kopla in my recognition system. I have not trained this model. I am not seeing anything out of this stuff. So probably you will be given with this Mysuru and Bhagapur. Normally, what we do in our traditional machine learning algorithm, if what a new classes comes into picture, what normally we do?
It will be matched to the closest matching.
That is different. That is different. My question is that what normally we do in the traditional machine learning, if the new class comes into picture. Let's take an example. You have 4 face images. Now let's take an example. The 5th one comes. That is what, of course, a new class. You have to add it, right? Normally in traditional machine learning, what we'll do, what we will add this to our existing. We retrain the model and finally we does it, right? This is what we do. So whenever the new class comes into picture, so probably what we have to insert into our database, we have to run, we have to get the samples, and we have to make this train, and finally it turns out, okay, finally at the set, so probably it is a 3-class problem. So this is what the traditional machine learning does. But finally, if you want to understand what exactly what few-shot learning is all about, as I mentioned in the earlier slide, that the main aim of what few-shot learning, it's not to build a recognition system. It is only for finding out the similarity between the objects. If we are given with these samples, let's take an example with this one. This is of course a very interesting slide and a very important slide for one to understand more with respect to what the FSL is all about. Like you are thrown with these samples. Let's assume that you have only 1 sample for each class. This is 0, this is 1 and 2. Now let's take an example. I will be given with these character as my test case. So normally what in FSL, how it does it, that you compare this image with respect to this image, and finally you find the similarity between these 2 objects. Now let's take an example. If I do some approach, let's take an example. I have come up with some features and finally I'm doing some similarity with respect to this one and this one, and let's assume that it is giving 0.9. And again, what I have to compare with this to this one, let's assume that it is giving 0.05, very less similar. And so probably again, if I give with respect to this one, 2 and matching with this 2, 0. So probably the similarity it is giving 0.1. Now where it goes? So probably the highest similarity with respect to this image, and finally I'll tell, okay, this image or sample is very close to this sample. This is what we do in few-shot learning. Rather, we don't want to recognize an object, something like that. We don't want to what we are trying to do is that we have a lot of images, and finally we train the model, and finally we'll tell, okay, which is whether the sample is in the database or not, something like that. But here, the main key idea of few-shot learning is that we want to find the similarity between the objects. So in that way, it works. So let's take an example with respect to another case, like you have 0, 1, and 2. You have only 1 examples, and finally you have given with respect to the 9. Of course, here, like let's take an example. It is a known class, but when we take with respect to this one, it is 9. So of course, it is not in the database. You compare. You do with similarity. You compare with this one and this one. So probably let's assume that you are getting 0.3 and it is getting 0.05, and finally you are getting some 0.2. You fix a threshold and finally tell it is not in the database. So probably in this way, the key idea with respect to what few-shot learning is all about. And to make you much more what clear, like what exactly comparing the traditional supervised learning and the few shot learning is all about. So this slide helps you what understanding the same. Let's take an example with traditional supervised learning. Traditional supervised learning, how we going to do? We have a test samples which is not seen before. Of course, this image is not seen in this database. Let's assume that I have training 6 classes with respect to say 5 different samples in each class or something like that. So let's assume that the test samples what I'm throwing here, it is not seen before, and this test samples are known class. Of course, this is known here. I know this class. Okay, finally it is one way or the other way what it belongs to this one of the other classes. So probably what exists in traditional supervised learning, of course, you don't have any problem because you are training too many images, and finally whenever the new case comes, so probably what it classifies. Whereas few shot learning, you train normally what happens, you train the database which is of some other class, and finally you test the other one. So this is the key idea with respect to few shot learning. So here what I'm trying to do is that I'm training 0, 1, 2, 3, 4, 5, and I'm giving test as 9. So now another very important is nothing but the support set. When I talk about few shot learning, the very important point is the support set. I'll be given with the support set to help my model to do better. So this is my support set. And what it does, and finally this understands, the training set understand, okay, what are similar, what are not similar, dissimilar features, etc., everything you've done. And finally, when I give the test case, I give with respect to the support test. So finally, the system compares this to this one, this to this one, this to this one, and finally this to this. And finally, Mark said, okay, this 9 is very close to this object, and finally recognized as character 9 or something like that. So test samples are not seen before. Of course, test samples are not from unknown classes, are from unknown classes. So probably this is the key idea with respect to few shot learning over the traditional supervised machine learning. So traditional supervised learning, what is that? Of course, the test samples are not known, but the samples are from the known classes. Whereas here, let's take an example. I can give another way. Like let's take an example. You train all fruits, all fruits, vegetable, etc., Where in test case, I will give buses, bus, lorry, or something like that. System has to understand, and finally it has to give sort of differentiating between the buses as well as the fruits and vegetables. That is what the key idea of few shot learning is all about. So you are giving with respect to the support set. Support set really helps in finding out telling okay what the sample is all about, and finally helping in having some sort of similarity. So this is what the key idea with respect to the few shot learning. So
support set is included in the training set.
No. Support set is not included in the training set. Training set is entirely different here. That is what the difference between the traditional super learning to the few shot learning. The training set is entirely different. That is what I said. So these 0, 1, 2, 3, 4, 5 I train. Let's say take hundreds of thousands of characters I've trained. But in support set, I give only one card of the test case. Let's take an example. I'm giving 9 as a test, and so probably in my support set you have only one sample which is very near to this class. So I also give other, like you see here 6, 7, 8. Of course, it is not in the database.
No, it is not.
Yeah, training set. So probably your understanding of the machine has to able to tell. Okay, this 9 is match with this 9. So that is what the overall idea of few shot learning. Are you getting?
Yes, sir.
Okay. Anyhow, we'll have a couple of examples to show you in later slides. So probably I can show. That is what I said. Like you train all vegetable, fruits, or many other stuff. In while testing, you give elephant, or you tiger or something like that. Or when you give a support set, so probably this support set acts as a prior knowledge. Please try to understand. This support set acts as a prior knowledge, and so probably you'll be throwing with respect to some of the support set, and that support set helps in identifying or recognizing the character to belonging to a correct class. So that is what the key idea with respect to few shot learning. Of course, this is a real challenge, because what we are trying to do is say that you are telling the machine saying that these are all belong to one group, these are all belong to one group, these are all belong to one group. Whenever the new thing comes, so probably it should what differentiate between this to this. That is what the key idea with respect to few-shot learning. So that is what I said. It is not building with recognition system. It is only what trying to tell how different or how similar the two objects are. Okay.
Okay. So, sir, support set is only in case of the few shot learning, not in case of the traditional supervised.
Yeah, no. Yeah, yes.
Or,
In traditional, this is what happens, right? In traditional,
yeah.
this is what happens. In traditional supervised learning, you are given with all bunch of this thing. But of course, I know the class information here. Of course, I know this class information. Of course, this belong to any of belong to 0 to 9. And finally, with the variations and also probably I'm training huge amount of data. So probably I can easily figure it out. Okay, this is one. In the MNST database, what we have 50,000 samples being used for training, and only 10,000 will be used for testing. There are results like we have already achieved 100 out of 100. There are models where you can easily tell all 10,000 belongs to correct classification. I can easily do that one. There are a couple of research papers where it is 99.99% it is correct. So in that way it works. But whereas in few-shot learning, it will be not. So this is what the advantage is all about. You are telling a system these are something and this is something different. So probably in that way it helps you understanding the two objects are similar or dissimilar in nature.
Sir, in such kind of scenario, is it good to use the concept of deep learning? Because in case of deep learning,
that is what. Yeah, I will come to that. That is what the basic idea of what few-shot learning is all about.
Okay.
Okay, so when I talk about few-shot learning, it is something like K-way N-shot support set. Okay, K-way N-shot support set. So what is K-way? The K-way is nothing but the support set as K classes. Let's take an example in this scenario. This is what my support set, and how many classes we have? Around 10 classes. Yeah, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? So totally comprises of 10 classes. So the K is 10 here. And what is N short? N is nothing but number of samples that is for having for each class. Every class has N samples. In this example, you have only one samples. 0 has only one sample, 1 has one sample, 2 has one sample. So probably if I want to match this support set, and finally I can say this is 10-way, 1 shot. And coming to here, so this is 6-way, because you have 6 classes, 0, 1, 2, 3, 4, 5. And how many shots? You have for each class, I have 3 samples. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. So this example is related to 6-way and 3-shot learning. And this is 10-way and 1-shot learning. So probably you have advantages and disadvantages. Let's take an example. You have class size is too big and you have very, very limited amount of samples. And let's take an example with the short, the class size is small, and finally you have n number of ways. So probably in that n number of samples. So probably each having advantage and disadvantage. I can tell you giving an example like this, like prediction and accuracy. Okay. So as the number of ways increases, nothing but ways is nothing but classes here. As the number of classes increases, and so probably you can see here the recognition also decreases, right? Recognition accuracy also decreases. As the number of shot increases, let's take an example. As the number of shot increases, in this case, earlier we had only 1. Now I am just putting another 2. And that case, so probably accuracy increases. So these are the 2 important factors when I talk about the K-way N-shot support set means. So if you see a couple of very limited papers you have, of course, you will get hardly around 10 or 15 papers all together with respect to 1-shot learning and a few-shot learning. Very recently, last year and last before year, so probably you can see few papers are coming out with respect to these few-shot learning with many applications as well. And normally people the researchers will be doing with only this way, like K-way N-shot support set, like they talk about 6-way 3-shot or 10-way 1-shot or something like that. All depends upon the as I mentioned, the idea, like factors. As the number of ways increases, of course, you can see the decrease in the accuracy. As the number of shot increases, so probably you can see the increase in accuracy. So this is what a model is, with respect to the this prediction accuracy. This slide. So when I talk about any doubt here, please. Any doubts here in KV and shot?
I think no, sir.
Okay, actually, this is what the support set is all about. Someone asking like, what is this support set? Support set is all about this one. So, how many support set you have? In what way we have? Like you have 10 ways or 1 shot, or 6 ways or 3 shot, or many things, something like that. Okay. Normally, in this case, it is what? How many? Can anyone tell me? What is this support set size?
4 classes.
One, yes, one. Yeah, 4-way, 1 shot. 4-way, 1 shot.
4-way,
1 shot. Okay. So of course this is challenging, right? Because you have only one. Let's take an example. If you added another 6, 7, 8, 9, and 6, 7, 8, 10, so probably your chances of accuracy may increase. So this is how it looks, right? Okay. So we have to understand about the variations. When I talk about few shot, we have generally what researchers have identified into 4 different types. N-shot learning, I can call it as NSL, N-shot learning. It also means that few shot, 1 shot, 0 shot learning is a subfields of NSL, that is the N-shot learning. Otherwise, few shot I can call it as, otherwise I can call it as 1 shot learning. Less than 1 or 0 shot learning. So there is less than 1. I can call it as a 0 shot learning. Of course, there are a couple of work have been also done on this line, 0 shot learning, where you don't have anything. You don't, like even in this 1 shot learning, at least you have support set of samples relating to that. 0 shot, you don't have anything. Entirely you train something different, and finally you give something different. So probably how your system able to differentiate these two classes is that all matters here with respect to 0 shot learning is all about. So N shot learning, it's of course a broad one. All put together, I can make it as few shot learning, 1 shot learning, and 0 shot learning as subparts of N shot learning. So how are we going to approaches is very, very important. So probably you have a problem, and finally how are you going to approach this problem and how to go to solve this problem. Okay, so when I talk about the training set, is nothing but the support set here that consists of K class labels and N labeled images. Of course, a very, very small amount here, less than 10 samples per class normally. And Q is nothing but the test images. So what we have to do is that we have to classify this Q test image among the K classes, and then N into K samples in the training set are the only examples that we have, right? So this is what the idea with respect to the few shot learning and the approaches. As I mentioned, like you have N K ways and K way. Sorry. K-way and N-shot. Okay. Okay, so this is what an example here. So this is my test images. This is my support set. So 0 to 9 I have, and this example is 10 3-way, 10 3, and this is what my test. And so probably what I have to do is that I have to, based on these, I have to correctly tell that this belongs to this class, this to this, etc. Okay. Right. So coming to the very interesting topic, as I mentioned earlier, learning to learn. It also means the meta learning, which intend to design a models that can learn new skills or adapt to the new environment rapidly with a few training examples. Okay. So yeah, this is very good examples to understand the meta learning. So let's take an example. You have built a robot, and these robot you are trained in a plane surface. Let's take an example. You train this robot to walk or run in this plane surface. Now let's take an example. If you take this robot and finally put it in a different environment. With this, the environment is of course not used in the training. So probably how your model or how your robot will really work. That is what the challenge. That is what the idea of meta learning. So it's something like a robot completes the desired task on an uphill surface. Test even through it was only trained in the flat surface. So this is what a best example to what understand with respect to the meta learning. And the applications can be guiding the policies to natural language, automation of factory operations, learning optimization. Of course, natural language processing these days really what going in a different way and different problem because of the social media and all. People now use what language processing to do many other tasks and finding out the behavior of a human, many things, stuff, something like that. Of course, a great deal of what research is also working on this. So when I talk about approaches, I can solve these few shot learning with these three approaches. One is prior knowledge about similarity, another one is prior knowledge about the learning, and finally last one is the prior knowledge of data. So let me take the prior knowledge about the similarity in this what example and try to understand how exactly what we are going to deal with the similarity way. So what is the basic idea? And the basic idea and example is that first we have to, as I mentioned, we have to learn the similarity function from the log databases and then apply the similarity function for the prediction. You compare the test with the sample with the support test and find the simple with the highest score. This is how what normally goes here. So probably I can show you the board here. So the key idea is something like you have to find the distance of image 1 to image 2 is something like what it is something like degree of difference between images. Okay, so now what if this distance of image 1 to image 2 is less than, let's take some tau as a threshold, and then you call it as similar. Or if this d of image 1 to image 2 is greater than the tau, then you tell it is different. So this is what the verification is all about. This is what you do, right? So let's take an example. If you have a signature, as an example I will take, let's take an example. I put the signature like this, and you have another signature, something like this. So I go to bank and then I put like this. Okay. Now what we are trying to do is that we are comparing this to this. So probably let's take an example. The distance between this is very, very less, 0.1, and this happens to be very big. So probably I can call it as the degree. Yeah, what the distance between this image and this image. So finally, what it matches? The value is very, very number. So probably it is less than the threshold, and finally I will tell it is similar. So this is what big, and finally it is different. Okay. So if you consider another one like something like that, A, B, C, and D. In my database, this is what the characters I have. Well, let's take an example. I have something unknown. I'm not seeing anything in this in my database. So probably again you do the same. This is with respect to D of I'm computing what distance between this image 1 to image 2, this image 1 to image 2, this image 1 to image 2, and this image 1 to this image 2. So this is how what the FSL works with respect to the similarity. This is what we do. We do pairwise operations. Of course, while training, we do the same. We train. Let's take an example. We make a pair saying that these are similar, and I give 1 as a class level, and I also tell that these are different. So we have to do in many other ways, and tell it is dissimilar and it is 0. And let's take an example, E to F. This is dissimilar, you give 0. Likewise, you have to train all your training set will be like this. And finally, what test set? Something like that. Let's assume that you are given A to X trained in all different ways, and finally you use Z. And the support set is something like X, Y, and Z. Or let's take an example, yeah, A to Z, Y, and Z. And finally, using these two support set, so probably what you have to learn. Because already you have seen here, you have learned many things here. You are told that these are similar and these are dissimilar. So probably given this support set, so probably your system should be able to what tell, okay, this is what similar and this is not. This is different. Okay. So in this case, what happens? E is totally what it is. The threshold is too high here, and finally you can say it is not in the database. You can fix another what function and finally say it is not in the database. So this is what the basic idea with respect to what few shot learning. So this is what I have written somewhere. Yes. So D of image 1 to image 2 is nothing but degree of differences in the image. You calculate if it is less than some tau, you tell it is similar or same, or if it is greater than that tau, and finally you say it is different. So during recognition sign, this is what happens. You have a database and you give this one, and you give only one sample. You are given only with one sample, and this is what the test bed. And finally, what you compare with this to this is nothing but the pairwise operation what I'm doing. And finally, you extract some differences and finally tell, okay, if it is less than tau, it is similar. If it is greater than tau, it is different. Okay, coming to the very important idea, when I talk about one-shot learning, it is something like Siamese networks. Okay, Siamese is twin network. Okay, someone asked like how exactly Siamese networks are. Siamese what involves the idea of what convolution and neural network. This network is something like a CNN. Convolution in neural network, and all embeddings comes into picture, finds the similarity, finds the using the sigmoid function. So probably I can say, okay, whether these two characters are similar or not. So probably I can write here and I can explain how exactly this whole operation works. Okay, let me take signature, something like this. And you take another one. You have to make a pair. Okay, so you give this to a network. In this case, this can be ConNet, convolution and network, or your convolution filters. You do convolution operation, mini filters, and finally ReLU operations, and also what max pooling, many stuffs. And finally use a softmax to reduce the dimension. And finally, does all. So probably I'm not explaining this one. These are all conventional CNN works. Conventional. So you have this network, and finally, what you get the embeddings. Of course, you do the same here, and keep in mind the weight doesn't change here. Whatever the weight you fix here, so probably will be remain same for this network as well. P and yeah, let's take an example. This is I and J, and this is what the function of I, and this is what the function of J, and this is what the function of I, nothing but embeddings. Let's assume that I get 64 or 128 embeddings. Let's assume that I will get 64 embeddings. It's nothing but features, dimension. Of course, I do get for this. And finally, I will pass it to a similarity function. Also, access of peer knowledge. Okay, similarity function, and finally use the sigmoid function to separate whatever you give. So probably saying that it belongs to class or not, something like that. The output of this is something like different. I require, because the signature is different from the other, right? So how exactly overall, these are what the overall process works. So you have a signature, and then you send it to a network, and finally you will get an embeddings. Let's assume that you get a 64 embeddings. Of course, you get the same here. And finally, what the similarity function, what it does, so it is f of I minus f of j to k. So something like Euclidean distance I'm talking about here. And finally, this is what you do. Like you have a vector, you take a difference, and finally you have 64. So for all 64 you take I running from 1 to 64. Function of I to k minus f of j to k square. So finally we will arrive with only one element you get, and you just squish it into sigmoid function, and finally or otherwise also what I also suggest what give this element, these two elements to some similarity like cosine similarity. We can also try that one. You can also work on cosine similarity. It is xy cos of xy is equal to divided by x length dot of y length, something like this. So I'm sorry if it's wrong. I think this is right. Okay. And finally, the cosine similarity gives a value ranging between 0 to 1. Let's assume that if it is 0.2, then you can say that, okay, this is what it is different. If it tells 0.9, so probably you can say it is similar. So this is what the idea. And finally, this sigmoid function, you switch it to sigmoid function, and the sigmoid function normally what it is nothing but I cap of ij is equal to the sigmoid function. You have weight and bias. Same thing here. Mod of fi k I minus k square plus the bias, and it belongs to 0.1. So this sigmoid function has the weights and bias. Whatever the value you get, so probably finally what it gives it throws some values, and finally based on that you can categorize, okay, whether it is 0 or 1. 0 happens to be dissimilar and 1 happens to be similar. And also what normally when I talk about these architecture Siamese network, they also talk about loss. Right? Very, very important, right? It's nothing but a feedback way approach. Like you know the class information. Anyhow, I know this one class information. I given with this class information saying that these two are different. I say. Okay, so this when I talk about loss function, it should be minimum, right? Always the loss function should be minimum. We can use the logarithm function. That equation, everyone knows that one. We can use this, and finally what you run many times, and finally what you train the system saying that, okay, these two are different, something like that. Whenever like the two signatures looks alike, so probably you tell the system these are the similar one, and you train many ways. And finally, whenever you get the test case, let's assume that you get a test case, and finally, so you compare with the support set, and finally, there's the job. So this is what the overall idea of what Siamese network. Siamese is why Siamese? Siamese is twin networks. Siamese is twin. So because you are pairing this and this. So that's why the name called Siamese twin network. Okay. So interesting is that normally people use this CNN, all ReLU, MaxPool, and all, and finally. So question is that also probably what one can also use other techniques. Not why rely on only these conventional. So probably you can also work if you have something in mind. So probably you can build this system and finally work and have a knowledge with respect to what one-shot learning and what is few-shot learning is all about. Okay. Fine, and then coming to the applications. So did you get it? Any doubts here, please? Any doubt? Any clarifications? Okay, fine. Okay, so the applications could be in computer vision, natural language processing, robotics, acoustics and signal processing, and of course the other applications. And very importantly, what is the core issue here? So the core in machine learning, there are prediction errors, and one cannot really obtain the perfect predictions. The core issues of what OSL or FSL is based on error decomposition. That is what the minimum error rate. Okay. So whenever I talk about, so the main idea is the main goal is that you have to reduce this error, right? You have to reduce this risk. Error should be very, very less. So probably in order to reduce this one, what I have to do is that these are the three important way I have to improve my model. Okay, it is with respect to the data, it is with respect to the model, and it is with respect to the algorithm. Okay, I can use some simple example like how people work with the data, a model, or an algorithm. Let's take an example. You have only one sample. There are research being done on augmenting the data. You have one, and finally you make many out of that. So means to say that, let's take an example like this, data augmentation. Let's take an example, you have only one sample, and you create hundreds of other something based on this zero image. Like you can tilt in different ways, and you can make it as samples, and also you can to make your system robust, you can include some noise densities, etc., and you can do some breakages or something like that. You try to create huge numbers with this one. So that's where the idea of data or the data augmentation comes into picture. Okay, and the second one is with respect to the model and algorithm. Of course, algorithm plays a very important role, no doubt. So whatever the algorithm, I did talk with respect to CNN or something like that. So probably you coming with some sort of structured way. So probably really helps to design my model in a better way. Okay. So this data and of course model and of course the algorithm normally goes hand in hand in solving this FSL or OSL problem. Okay. Fine, and we'll stop at this point. So next class, so probably next session I'll be taking on the case studies. If you have any doubts, please let me know so I can clarify it. Any doubts still here, please? Are you able to catch?
Yes, sir.
Okay, are you feeling like interesting this field? Because this is very, of course, I told you that it's very immature. Very little amount of work have been done in this line. Understanding these, developing these, so probably really a real challenge. Of course, the main disadvantage is something like there are many cases like you have only one samples or two samples, so probably there is a chance of overfitting your model or something like that. It is not that easy or straightforward. Probably designing your model is will be very quite interesting. So that is what the next session is all about. We'll take one study how we designed our model, and finally we adopted the idea of one shot, and finally we will show the code and all MATLAB, using MATLAB, and then we'll finish it off. Okay. Any doubts? Dear participants?
Sir, can you give us a brief idea about how this semi-supervised learning will work? Because nowadays the most of the concept, and many problems are being solved with the concept of semi-supervised learning. Yes, we know that in case of semi-supervised learning, a few data are labeled data and most of the data are unlabeled. So yes, so in such case, it will be very difficult, to train our model in such a way that it will give the desired output.
Yes,
so
that's true.
Yes.
Yeah, actually, as I mentioned, like when I talk about learning categories, it is like supervised, unsupervised, and reinforcement learning. So probably there is what a bit of challenge with really we have with respect to the semi-supervised learning, as you mentioned. So some data we have some labels and some data we don't have. So probably if I want to put in other way, let's take an example. Semi-supervised also what researchers have also tried. Let's take an example with solving the images problem. They have taken some ideas with respect to the prior knowledge about the texture information. Let's take an example. There are a couple of places where humans can't reach. And there are you see some extinct animals available in those sites. But everything we have learned, you don't have visual information about those animals or something like that. But only you have very little amount of textual information which you have read in the browsers or resources or something like that. So probably the idea of multi-model algorithms or the multi-model approaches, so probably what helps in solving these semi-supervised learning approaches.
Okay, sir. Thank you.
Okay, but obviously, these days, whatever we see in the research, so probably it is broadly classified into these three. So semi-supervised, of course, as you mentioned, really challenging, lot effort. Also, with respect to the model data and all, it is required. Finally, what I say is that building an efficient model is, of course, a great challenge here. Okay, so we have to work on designing a model. Anyhow, forget about data. If you have one sample, so probably using the data augmentation technique or something like that, we can make it a big number. So probably the other way is that the building model, of course, plays a very important